Dear ladies and gentlemen, thank you very much for joining today's 5G Summit online event. 5G is the future of our communication, not only in the industry, but it will also have an effect on our daily life and understanding about the digital world, which will grow even deeper into our lives in the next years. Since lots of countries are talking still about 5G, South Korea was the first country to launch their 5G technology 1.5 years ago. In our summit, we'd like to get deeper to have a look in what is possible and already in use and what will be possible in the future. This event is hosted by the KOTRA European headquarters, and today it is my pleasure to be your host and moderator throughout the next upcoming day with a lot of valuable content and amazing speakers, both from Europe and South Korea. My name is Bobkoski, and I work in our marketing team here at Frankfurt. Our marketing team is responsible for organizing events like this, offline and online, B2B matchmaking between Korean companies and German companies is our main purpose, and therefore we are supporting to find business partners in the German market. But enough about us. Let's dive into our event, and let me briefly introduce to you today's program. The first topic is the role of 5G as a key enabler for successful digitalization of society and industry, which will be covered by Professor Dr. Engineer Hans-Dieter Schotten. Next up will be Mr. Simon Haag, talks about possible usage and the influence of 5G on local areas with strong industrial infrastructure. Also about the German situation in local areas with underdeveloped high-speed internet connections. Lastly, Mr. Michael Bobkoski will talk about the experience as Korean 5G antenna manufacturer in the European market and their results. Before we officially start our program, a few technical and organizational points from our side. Throughout the whole webinar, you will be on mute and your video will be turned off. Of course, you'll always have the opportunity to share your questions and throughout the chat box or Q&A box below. The questions will be answered after the event and sent to you. Now, our interpreter for English, Mrs. Hyung-Yong-Hong, please note on the shown PPT how to change the language channel. For English, no action is required. The event will be recorded, and the link to rewatch this event will be sent to you after the meeting, alongside the information documents provided by our speakers, so you will be able to share it with your colleagues. More about the following steps later. If you face any technical issue or related questions, feel free to send a message to Mrs. Lea Weber directly. First off, we are pleased to have Professor Dr. Engineer Hans-Dieter Schotten. He is member of the VDE Presidium and member of the Information Technology Society, ITG. Professor Dr. Schotten is Director of the Intelligent Networks Research Department at the German Research Center for Artificial Intelligence, DFKI. And Chair for Radio Communication and Navigation at the Technical University of Kaiserslautern, TUK. Hello, Professor Dr. Schotten. Great to have you here today.
Good morning and good evening.
How are you today? And of course, we are all hoping for a good presentation, and I'm sure our guests will value your presentation very much. So let's have all a warming welcome to Mr. Professor Dr. Schotten, who will start now. Mr. Schotten.
Yeah, good morning and good evening. It's my great pleasure to be invited to give this first presentation to you today. So also welcome on behalf of the VDE and the German Information Technology Society that I have the honor to be the chairman of. And on behalf of these organizations, I would like to give you a brief overview on what the VDE and in particular the Information Technology Society is doing, and in particular, of course, what is happening. So what are the upcoming trends with respect to mobile communications, where 5G is certainly the most important example, but the 6G story is already starting, and we are seeing first discussions on this, as I understand, in South Korea as well as in Europe and Germany. Yeah, the VDE is the German Association for Electrical, Electronic and Information Technologies. It's one of the largest technology organizations in Europe and actually even in the world. It stands for Innovation and Technical Progress. It was actually founded around 125, so it's now 126 years ago. And Mr. Siemens himself was heavily involved in this, so it goes back to the very initial steps when it comes to electrical engineering. VDE is the only organization that combines science, so scientific working groups that deal with academic questions, as well as standardization, certification, and industry harmonization. Additionally, of course, we are heavily involved in doing consulting for society, so defining recommendations, but also for policy decision makers. In Germany and other countries, since the VDE in the meantime became an international organization, so the VDE mark has been synonymous for highest safety standards, so it is used as a mark that guarantees certification processes that are the most well established in the world for certain products in electrical engineering. In particular, of course, when it comes to advancement in technology for the education of the next generation of engineers and technologists, when it comes to caring about young professionals, we have a very strong position due to the combination of having the academic and the industry side in the organization. So we cover the whole career really from the first days at a university up to your industry career. And that's one of the very special situations that we are having here in Germany, so that we really have this very tight interaction between universities and industry work. When it comes to caring about our members, so the personal members, typically engineer, computer scientists, but also, of course, when it comes to representing expertise in the field of technologies. So we have a network of 2,000 employees in over 60 locations worldwide, so in many countries, and we have honorary experts. We have our working groups in which recommendations are generated, discussed, where in many cases we initiate standardization activities that then are partly also organized within VDE. Within VDE, the Information Technology Society is, as the name already indicates, the society dealing with information technology. So everything from microelectronic being required in information technologies, to services, to technology, to mobile communication, quantum communication, cryptography. So everything that is needed in this context is part of the Information Technology Society that I'm currently having the honor to be chairman of. It is one of the 4 working groups that we have in VDE. There's also one on electrical engineering, one on biomedical products, and one on microelectronic technology. So the ITG is very similar organized as VDE, so it combines business, administration, for example, regulators, and the academic world, covering teaching and research, of course. And it has its own broad range of working groups dealing with all the different aspects that I just listed. And of course, the idea is to promote research and application of key technologies in different areas. These working groups are typically open and very much, of course, interested also to build international networks. So they also have members from other countries, of course, mainly from Europe. but the representatives that we have are typically from all countries over the world, at least from those companies having offices in Germany. So we typically have a very strong representation, as you will see later. So how is the Information Technology Society organized? So we are having 6 sub-organizations, one dealing with services and applications, one with media technology, one with audio technology, communication technology, technical informatics, and high-frequency technology, where technical informatics also covers parts of microelectronics to the level where it is relevant for understanding and designing ICT systems. And within, by the way, within these organizations, we have subgroups. We also have several special groups dealing with certain topics, upcoming new topics that require special attention, or where, let's say, activities across the different working groups are required. That's currently, for example, a major activity in the area of micro and nano electronics. Then a special project on mobile communications, because there's a very dedicated activity that we are currently seeing as part of our Corona recovery project. And so that might be transformed in an even larger activity in the future. And then we have a new activity, communication in space and atmosphere, so what we call new space communication, that is at least as part of the 6G activities, but also from a broader range, currently seen as a candidate for becoming a new infrastructure for the IoT and for other services. So that's a little bit the structure, and then we have many ad hoc groups working on defining white papers. So VDE and KOTRA have a link, so they are collaborating, and Dr. Christian Groß in VDE is a point of contact for this collaboration, and has already started a number of activities. You might partly, at least those working within the KOTRA framework regularly, know him. Yeah, so one of the typical results of the work is, of course, standardization. Here's just one example. So some of the ETSI working groups have their German correspondence as part of the DKI, Deutsche Kommission Elektrotechnik, which is part of the VDE. So that's a sub-organization of VDE, which is the counterpart of ETSI. Also, of course, as you know, the standardization work is, of course, done in 3GPP and then defined as a harmonized standard in Europe in ETSI, but the counterpart, the German part of this, is then the VDE. And as said, this role of these sub-organizations that I just mentioned, the Deutsche Kommission Elektrotechnik, DKI, is of course to be this national counterpart to ETSI, but also to some IEC groups, and it is responsible for defining the standardization process. I assume that you are familiar with the different standardization processes. And of course, this becomes more and more important as globalization is still, of course, driving an advancement in technology. And for this reason, we are happy to have an organization in Germany that combines these different steps, so that combines everything from university education up to standardization processes, because that allows us to very early explain these processes to our students and to young professionals, and to educate and train them in working in this environment. So that's the reason why you will find extensive activities addressing standardization processes in Germany, and also a lot of discussions about revising and innovating these processes. Okay, so some examples for recent activities that we have within the Information Technology Society. So what are the hot topics that we are currently seeing? So some are more coming from the political side. That's technology sovereignty is one of the most important examples. So we have a geopolitical context that is forcing us to revise our ideas about this, and that might certainly have an impact on how we collaborate in the future and which technologies get prioritized. It might have an impact on funding. It might have an impact on how we collaborate on the research, but also in the standardization world with other regions in the world. So it is important we are having a discussion, and it has a very high political priority for the time being. When we look more into the technical dimensions, so we definitely have quantum technology as one of the topics. So covering everything from quantum sensors, quantum communication, quantum cryptography, quantum computing. So the whole scope is covered in 2 groups. And the Information Technology Society is currently looking into this and setting up a new organization covering this topic, defining recommendations in the white paper on how to progress here. The next big topic is, of course, the advancements that we see in mobile communication. I will talk about this on one of the next slides. But as you might know, of course, we are in the initial phase of defining 6G. That's also happening in Europe and Germany, and that's where also the Information Technology Society is heavily involved in our working groups, but also even in the board. So then we have currently, driven from the AGVs, autonomous driving, autonomous robots, strong interest in advancement in radar technology and localization, ranging technologies. Photonics is also an important topic. So the international context is in these groups often seen as a key argument. So Germany is a country that is strongly interacting with many major other countries as South Korea. And for this reason, as I already mentioned, we have a very strong international participation, mainly by company offices in Germany in all our working groups. And just as an example, so in the board of the information technology, we have, for example, representatives from Apple, Nokia, and Ericsson, which are all, of course, no typical German companies, but represented in the board. So, role of 5G. So, of course, I guess you will know that we are having a very strong interest in applying 5G in the so-called vertical industry. So when 5G started around 7-8 years ago, the key idea was, and we were involved in defining this idea, to make the research spending efforts, so the global efforts, usable for vertical industries, because they are looking, of course, for possibilities to become more flexible, to support mobile applications by having wireless technologies. So, and there are several reasons. So it started with, okay, we understand wireless is good to have because it's seen as a key enabler for digitalization, because as said, so it enables mobile applications. It increases flexibility, so it's seen as a prerequisite for Industry 4.0. Less well known is that it's also providing a new convergence layer, so in addition to the IP layer that we have today. So this is partly in the German industry seen as one of the most important options when you really talk to technical experts. So we get an Ethernet convergence layer, which allows to integrate field bus technologies, TSN, and other things. Also in the multimedia section, this becomes important. So that's often not so well understood, but this is probably one of the strongest arguments for 5G. And of course, in general, with wireless, you can replace cables, you can have reduced maintenance efforts, and that is just reducing costs. That's also a strong argument. And when we talk about wireless, there are, of course, other wireless technologies. So we have, of course, the IEEE efforts. We see that DECT is currently developing a very interesting roadmap. So there are other options. And of course, there is a competition by Wi-Fi 6, 7 to 5G, but nevertheless, 5G is seen as the most promising technologies. We're having a number of problems. One is, of course, as mentioned, technology sovereignty, which is kind of abstract definition of the problem on the political level, but the more detailed things are we need spectrum. And that was solved in Germany by assigning dedicated spectrum, so the 3.7 to 3.8 gigahertz spectrum for campus networks, for non-public local networks. This is a very unique step that was done in Germany, and that is currently seen as a reason why we have this extremely strong push for campus networks coming out of the German market, because we have 100 megahertz dedicated spectrum available. The second problem is, of course, product availability and openness of interfaces. Here, Open RAN is, of course, often seen as a potential step forward. But for the campus networks, a new market segment is defined, and it needs to be seen how exactly the product availability is guaranteed in this segment, and in particular, of course, also the future-proofness and the sustainability, sustainable migration path. Then there are a number of things that are less technical, but where VDE might be the solution. So there are liability issues, certification, product qualification issues, where we in the meantime have several groups, 5G ASEA being the most important one. But that's certainly also something that has a high relevance, where working with organizations in Germany is important and where we are very active. And then, of course, there's a big issue when we start to invest in 5G from vertical industry perspective. So is this really a sustainable migration path? So do we have a guarantee for the future proofness? And that's where the answer is we are now working on beyond 5G, 6G in particular, with a focus on how that can be used for vertical industries, and also with a focus on campus networks and their migration paths. Okay, so when we look into industry, a number of organizations were created, and at least the 5G ASEA was actually created in Germany as part of the ZVEI, which is another industry organization that we have in Germany. Actually, we have many industry associations, yeah, so there is a strong tradition to have these. And the 5G ASEA was founded as a subgroup of the German ZVEI, but is in the meantime the largest international organization for working on 5G for automation and production industry. And let's say the counterpart in the automotive sector is 5GAA, which also has a strong impact in the German market. In addition, VDE, but also VDMA, so the automation industry and the electrical engineer has its own working groups dealing with campus networks, dealing with wireless communication, also comparing, of course, Wi-Fi 6 and 5G, 6G technology. Then we have public funded projects that in some cases are also open to external companies. So we have many bilateral programs with other countries. These kind of programs also exist with South Korea. We also have national funded projects. The 5G ASEA, as example, was founded as part or as a result of a German research program. Yeah, so it was a German research project that initiated the foundation of 5G ASEA. And they are open for participation of all companies having offices in Germany, so legally independent offices in Germany. But as said, there are binational programs and also with South Korea. And then we have many specialized spheres. So when you think about 5G, CMM, connected mobile machines, one a new fair organized by the Hannover Fair Group, but also the Hannover Industry Fair itself are probably the most important examples. So I mentioned verticals, and what you can see here on the lower part of this slide is examples for the many use cases. So why is automation so important? Simply because it's combining on limited local area many different challenges and applications in a very dense room, so that we have challenging requirements here. So it's seen as a gold standard in the industry. But there are other examples like agriculture, health, hospital infrastructure, logistics, where we are currently working on in Germany with significant resources as well. And where certainly you will find many opportunities to work on. Okay, so that's now my last slide. So beyond 5G and 6G. So I know that, of course, there are many discussions on this already ongoing in all regions in the world. So we are currently discussing to invest in this. So under the buzzword 6G, Open RAN, campus network. So these are the three dimensions that are currently seen as top topics. And so the details about these programs are not yet completely known or not yet publicly announced. But there is a strong discussion to have something as part of the Corona recovery actions in Germany in this area. That might be a major activity, and definitely there will be something on the EU level, also potentially addressing 6G. That is also not yet completely finalized and will be announced in the next weeks. So you can expect to see significant announcements in this area very soon. So when talking about 6G, what is 6G? So we do not yet know what 6G is. So it's currently seen as a kind of a buzzword for the next step in mobile communication. There are, of course, some initial ideas. There is a WRC process that already, and ITU process that already defines certain steps. So we do not yet know whether it's a full network or just a technology enhancing 5G. So there are different options that are currently under discussion. So it's a good point to start and to participate in this, and also to build a network around the world on somehow shaping the vision on 6G. The main topics that we are discussing in Germany are very similar to what I have seen from the Asian countries. So nothing surprising, like millimeter wave, like new HMI, security, improved coverage, of course, cost reduction, openness of interfaces, and all these topics. But a very special situation might be that in Germany, due to the strong role that the automation and the automotive industry play, we will probably again look at campus networks as an area where significant contributions can be expected to come from the German side, and where also the VDE and information technologies working groups will participate in the discussion process that we will see. Okay, so that's a little bit an overview on the different aspects. So you might know that as in all countries in the world, there are also, of course, regulatory processes targeting the next auctions. But they will probably follow a little bit the vision and the concept of what we have seen in the last. So we are having this campus network idea, so we will see a broader ecosystem in mobile communication, but of course network operators will remain the key players in this system. Good, thank you very much. So please do not hesitate to contact me if you have questions. Here you have my email addresses at the university and at the DFKI, the German Research Center for Artificial Intelligence, where I'm one of the directors of. Thank you very much.
Thank you very much for the great speech and input, Professor Dr. Schotten. It's interesting on how many fields the VDE is interacting and observing. We will send you the follow-up questions directly to you after the event. And we are looking forward to continue the great cooperation between VDE and KOTRA. For our audience, of course, questions you can always put, please, in our Q&A box. We will then refer them to you, of course. Last up, it's my pleasure to welcome Mr. Michael Bobkoski. He is the head of overseas sales at Gamanu in Korea. Hello, Mr. Bobkoski. Welcome to our event. We are happy that you could join, even we know that the time difference is a big burden for you. Anyway, thank you and welcome, and please have a big welcome to Mr. Michael Bobkoski from Gamanu. Michael, you can start now.
Okay, thank you very much. Yeah, it is a bit of a time zone difference. The conference for me started at 3 o'clock in the morning today. So I will be glad to begin a presentation of Gamanu, and we are a South Korea-based antenna manufacturer. I'm going to put all my contact information on the screen, and you will be able to see that. You'll also, of course, be able to contact via KOTRA later on. So I'm going to share the screen now. Okay, I'm going to present an overview of the Gamanu company and company history. And I think, as you can see, antenna issues encompasses really what is the final interface in a wireless network, and that is the air interface. And many people believe that the air interface is the most important part of a wireless network. Consistent beam control is mandatory for network optimization. So making things more difficult is the fact that antennas cannot be of just any size. Antennas must always be as small and light as possible, and they need to be as visually pleasing as possible. I'm also going to talk about 5G antenna trends. And of course, there are various stages in any technology, and we're going to talk about where we are right now with 5G and where we think as a company that 5G antennas are going to be going. These are the 6 general product areas or the 6 general categories of antennas that we manufacture, and these are quite normal antenna categories. Stadium antennas, which are used in various types of large venues, football stadiums. These were used at the Luzhniki Stadium in Moscow for the last FIFA Cup. Our small cell antennas, these are the sort of street level antennas that are put up using a pseudo-omni pattern for CRAN densification. Base station antennas, of course, you're all familiar with those. Those are the antennas that you often can see on rooftops and that people complain about sometimes. In-building antennas, sometimes you see them, sometimes you don't, but they're more or less everywhere in the buildings that you're in. Tri-sector antenna, this is also sometimes known as a cylinder antenna, and these are a little bit newer market segment, and these are quite popular within the entire European area now, as sometimes regulations about zoning and visual pollution are not allowing always the conventional tri-sector flat panel base station sites. So these cylinder antennas put 3 sectors into a tube, much more visually pleasing. We also manufacture pre-made camouflage antennas, so they're kind of a lower cost solution to making customized camouflage antennas. They can look like various things, like this one looks like a speaker. You can put those on a subway platform or any place that you might expect to see a speaker. I'm going to give you a little bit of just a basic history of Gamanu. Founded in 1997 in South Korea. 2002, we began to expand as a manufacturer. 2012, we reached $45 million total sales revenue. In 2014, we were listed on the Korea Stock Exchange. 2015, we established our North America office, out of which I actually operate. 2016, we were selected as 5G densification key supplier by AT&T, the American operator. 2017, we were authorized as an approved vendor for outdoor small cell densification. 2018, we began launching the cylinder antenna in a larger way into the European market. In 2019, we were selected as the beamforming 5G antenna by SoftBank in Japan. This slide presents kind of an overview of where Gamma Nu stands in the global picture of antenna manufacturers. As you can see, we're about in the middle. If you look at, there are some names on there that maybe some of you are familiar with if you are in this area, that you know the antenna market. And we're an agile manufacturer. We do have the capability of producing 10,000 antennas per month, but we are also large enough to be a serious competitor. Overall, if you talk about Gamma Nu, we're the market leader in BTS supply for the South Korean market. As I said, we can produce 10,000 antennas per month. In 5G, as has been mentioned earlier, Korea was the global leader in terms of deployment and testing of 5G, and Gamma Nu actually supplied the antennas for the Pyeongchang Olympic Stadium in 2018. So we were involved in one of the first functional large-scale test 5G trial networks in the world. We are Japan 5G approved, as I mentioned. This is an 8T8R beamforming passive antenna, and we'll talk more about that later. We have implemented warehousing in Poland. We do have a history of European supply that goes back more than 10 years, but things have increased lately, the past 2 or 3 years, and we've implemented warehousing. We can ship from that warehouse to other places within the European Union, or we can ship directly from Korea, depending on the individual situation. We also do, of course, have an office and warehouse in the US, that is in the state of California. Here is a look at one of our Korean factories. And as I mentioned, we have a manufacturing capacity with an 8-hour shift of 500 per day. So we can reach 10,000 antennas per month overall. Here's another look at some of the aspects of our manufacturing facility. We have the cutting machine, we have the production line view. I'll talk more later in more detail about PIM testing, which is passive intermodulation testing. Here's the second line where the antennas are all tested for a second time, and the packing, and of course the warehousing before they are shipped. This is an important aspect. The manufacturing execution system is a unique aspect of Gamma Nu that we have not seen, and which has been very popular with our customers all over the world. Manufacturing execution system controls every aspect of manufacturing, production, maintenance, shipping, and manpower. It also, most important to the end user, logs each and every antenna with the QR code, and I'll back this up once there, with the QR code scanning on every antenna and every antenna box. The Gamma Nu end user can look at the test data of his antenna. So he knows what test values the antenna had at the beginning. And shipping damage is quite rare, to be honest. So usually a lot of time can be saved of looking for a bad antenna. Maybe you have a DTF, you have a distance to fault measurement, and you think it might be the antenna. Well, it could be a connector, or it may be the antenna. But if you look at this, you will know what your antenna tested at when the antenna left the factory. Low PIM, as you see at the top of the page, on every page, PIM-free antenna is the official slogan of Gamma Nu. And PIM-free is something that it's a focus of our CEO and founder, Dr. S.G. Kim, and it's something that he has been involved in and he has been interested in really since the beginning of interest in passive intermodulation back in the days of UMTS. PIM is something that can enter into an antenna from many sources and paths, up from the connector, through the phase shifter, or direct to the radiating elements. An electromagnetic wave passes through each and every component of an antenna. You can't really fix this after the antenna is made. You have to build it in. And this is something that really comes with experience. And as 5G becomes a much more rich connection in terms of what people are doing with 5G and the ubiquitous nature of it, and the fact that it can be used really as a complete link, complete wireless link, PIM can have a very detrimental effect on signal strength, and obviously cut that back. In terms of supply chain control, all plating and soldering is critical. The manufacturing design elements that which we have learned indicates that anything that comes in with a burr or has bad plating or any type of small defect on a component cannot be built into an antenna which is of a low PIM design and then produce a low PIM result. So supply chain control is extremely critical on the process. As an example of the size of South Korea, Germany is about 3 times bigger than South Korea. Most of our supply chain is located where we are, which is south of Seoul. And this is in kind of a corridor where you have Samsung and a lot of other high-tech manufacturing. And really as a result of this compact supply chain, one side benefit has been that we've had no COVID-19 impact. The factory has been running full strength all the time. We had no shutdowns, and we had no problem supplying any of our customers with on-time schedule that we had previously made. High yield manufacturing. This really results in lower costs per antenna in the ultimate end. It is necessary to have well-trained and experienced workers, and it's also necessary to ethically treat them, so as to maintain a stable workforce which is well-trained. South Korea has strong labor regulations, and Gamma Nu is no exception to that. Factory conditions are up to a standard for high-quality manufacture, and all of the antennas that we ship are manufactured in that South Korean factory for the European market. Here's a very interesting aspect of Gamma Nu, and it's something that we have not seen, and many people have told us that this is unique to Gamma Nu. This is multi-band simultaneous automatic PIM measurement, and that's passive intermodulation measurement. In this system, Gamma Nu simultaneously multi-band tests on our own manufactured PIM equipment each and every antenna before the antenna ships. I'm going to show you a complete film of this, which will run through the whole process, including barcoding. But here you can see on this screen, you can see the whole process taking place sort of simultaneously, what is happening. I'll change it here and we'll go into the actual film. And you will see scanning in, air pressure connectorization to the antenna. All of this process is fixed automatically so that the operator has no control over the system. So whatever parameters have been set by management is what must be passed. If an antenna doesn't pass, it's automatically kicked out of the system. It is logged in, and the antenna has to go back into rework. We believe because this system vibrates every antenna at 7G vibration, it's a much more standardized test than testing each individual port and then tapping on the connector with the end of a screwdriver or some other type of human type interaction that has many variables. So this system is very fixed and very standardized in terms of testing each and every antenna. Thermal shock is something that we get asked a lot of questions about. You know, antennas can be mounted anywhere that people live. So they can be in any kind of temperature extreme in any country, and they can be in places where there are great temperature shifts between between night and day, depending on what time of the year it is. Also, antennas can be used in urban environments where you have extra heat sources in the summertime, like an air conditioning outlet, or maybe even some heat outlet in the winter, so that the antenna can go through a wide range of temperature shift throughout the day. Gamma Nu goes beyond normal testing procedure with our antennas, in that the standard testing procedure that you would see on a PBOSTA data sheet means that the antenna has been cycled. It's gone through high and low temperature testing, -40 to +70, but then it cools down to room temperature or cools down to ambient lab temperature before the antenna is actually tested, PIM tested, or VSWR checked. We've taken Gamma Nu antennas during our design process, and we test them at the extreme temperature. So we test them while they're hot, we test them while they're cold, and then we test them again at the ambient temperature. And they obviously pass those tests. Now we're going to talk a little bit about antennas themselves and some of the trends that we are seeing now in terms of what is happening, what was happening, and what we think is going to happen. And as you notice on the slide, it says for 5G and also supporting LTE, because we believe that the two technologies are going to coexist for some time. And based on different countries, they can coexist for many years. There will be countries where LTE is used for, you know, a long time yet alongside of 5G. Here's a question that we hear very often, and that is, will 100% of 5G sites deploy active massive MIMO antennas? If you look at the three charts, this is from an Ericsson study from 2018. You see that on the far left, the bar graphs are all of one color. They're entirely white, and there's a very high capacity gain with the massive MIMO antenna in an urban, very dense area where the antenna is not very high. You know, but you have high-rise buildings and you have a very dense population. As the population density decreases, you get relatively less benefit from the capacity gain of the massive MIMO antenna. And as we all know, and I think we saw it in some previous slides by the last presenter, massive MIMO sites take a lot of power. They actually use a lot more electrical power than people were anticipating. and they really don't offer significant or really any capacity gain over an 8T, 8R passive beamforming antenna. So we believe that it is more cost effective, and this is a trend in the market overall, that cost effective 8T, 8R passive beamforming antennas will be considered for the better solution for sub 6 gigahertz 5G densification. And we'll talk more about these kind of antennas in the next few slides. In terms of what we are doing for 5G ready antennas, this slide shows some of the various types of antennas which are based on current day antenna. Some of them are legacy, and then we also show the differences. On the left side of the page, as you see, you've got the macro cell antenna, which is your main BTS, your large antenna that you can see on like on a rooftop or on a tower. You have a single panel. These are directional type antennas. So these antennas would normally have each individual sector would have maybe a 65-degree horizontal beam width. They might have a little less, but usually around that area. And these antennas are currently used today in this legacy platform. We are also producing in the hybrid platform. And the hybrid platform combines current day technology, LTE. It also blends in the TDD 8T, 8R, 3.5 gigahertz, actually 3.5 to 4.2 gigahertz for the 5G C-band. The same thing happens with the trisectoral antennas, which we talked about earlier. These are the cylinder types, but as you notice, they actually have 3 sectors built in. This is a single sector antenna. This is for the Japan market, where they require a cylinder radome even for single sector antennas because of aerodynamic, because of wind loading. Normally, this type of antenna for the European market would be flat. And if you look on the other side of the page, we go to the small cell antenna, and here we move into antennas which take up a pseudo-omni pattern. So these are multi-port antennas, and I'll talk about an actual data sheet of one of these antennas coming up. But these are the types of antennas which are used for street level C-RAN densification. Here is one of those antennas. This is one of the, it's called a pseudo-omni multi-port C-RAN antenna. This is for the North American market primarily, but obviously nothing ever stays in one country typically. So we expect this type of antenna to probably see broader usage outside the U.S. These antennas carry from 10 to 18 ports. They are available in multiband 4T4R. Some of these antennas have RET, that means remote electrical tilt by pseudo sector. So even though it's not really a sectorized antenna, it is a pseudo omni antenna. Some of these antennas also do have the capability of down tilting individual pseudo sectors, and they operate typically in a frequency range for the total connector operation from 698 up to 5925 megahertz. Here is something that we have done creatively with that antenna. And this is that same type C-RAN street level antenna, except this one has a 120 millimeter conduit in the center. And you see this white space here. This is a conduit, so this is a hole passing through the antenna, which allows the antennas to be stacked vertically, or it also allows anything that you would choose to be run through the antenna. So if there is a local requirement for a light to be on top of a pole, you can still mount an antenna on the pole for street level architecture, for street level densification, and then mount a camera. In this case, it's a camera or it could be a type of particular lamp. And this is something that is commonly used for places where you have zoning regulations and you need to make the antenna look a certain way or make the antenna blend in better. This is one of the antennas I was talking about earlier. This is a more detailed view. This is a hybrid FDD TDD panel macro antenna, and this is basically supporting legacy technology today. So this is supporting your LTE. It's supporting down to 698 megahertz on the low band elements. It also has mid band elements from 695 to 2690. And then we also move up into the 3.5 gigahertz range, where on this particular model, it's 3300 to 4200 megahertz. And these antennas are very easy to install. They give 3-sector coverage, and they're able to be deployed. If you look on the photograph there, that really doesn't look like it's 3 antennas. It looks like a pipe, or it can be camouflaged. This is a fresh install. Actually, the radome was damaged when they installed it. There's some marks on it there, but this was just they will paint the antenna later on. But these antennas can be camouflaged to look like anything. It can look like a chimney, and they're often used in countries and places where there have been protests against antennas. There have been people don't like to see antennas, and I think you're all familiar with what's going on with 5G protests in various countries. These antennas have been used as a way of sort of alleviating some of those tensions by at least decreasing visual pollution and making the antenna fit in with its surroundings a lot better. And here is the 8T 8R beamforming antenna, which I was talking about earlier. And this is a single frequency, so this is a very compact antenna, very small antenna, because we're talking about 3.5 gigahertz antenna. This is for the Japan market, and that's why it is round. It doesn't necessarily, an antenna normally would have a flat surface. This has a round surface only because of the fact that it was made for the Japan market. But this is an example of what I was talking about earlier, of the direction of 5G, that this will be a very important component alongside of massive MIMO in the deployment of 5G. And I think that's the end. There's my contact email address and our company contact information. Okay, thank you.
Thank you, Mr. Bobkoski. This was a very, very interesting presentation, and I'm sure we all learned a little bit more about the fantastic quality of your antennas, and now we can also understand why you have been so successful on the European market. Again, thank you very much for your time.
Thank you.
Thank you all very much for your time and interest in today's event. As I mentioned before, you will receive a follow-up email from us, including the information documents provided by the great speakers and the recorded Zoom webinar file. We will get back to you, to your questions, as soon as possible. And now I want to move the attention to our B2B matchmaking service, which is scheduled for the last week in October. Here, we will introduce Korean companies, manufacturers, and suppliers in the 5G field and closely related fields to companies in Europe to schedule video conferences. European companies were able to tell us which product groups they are interested in while signing up for this event. We will reach out to you in the following week and introduce you fitting Korean companies or possible partners. For our Korean listeners, please let us know if you want to participate in our B2B matchmaking service so that we can introduce to you companies based in the EU. The B2B matchmaking service, which is scheduled for the last week in October, we will also provide you information how to register for it and everything, so you will have no trouble doing this. Stay tuned for tomorrow. As well, we will have speakers from the Korean Telecom coming up and a discussion session with German and Korean specialists who will discuss about safety and regulations, future outlooks and market trends. See you tomorrow, and please always stay healthy. Thank you very much for your attention. My name is Filip Sokolowski.